let's say that you've created an animation within control rig, so it's some kind of procedural animation, and you want what's happening based on control rig to do some gameplay events. So for example, it can play a sound, can spawn particles, whatever you want it to do. So here, we've got a character which is stamping his foot because he's annoyed that this isn't an inbuilt feature within control rig and we need to make a hacky workaround. And this is entirely animated within control rig. So there's no animation used. This is just control rig controlling where his foot is. And we do some pelvis offsetting. There's no reason for that. This could just be a regular animation. And then we could use some IK limits to stop the feet from going through the floor. So as you see at the moment, if the box is in the way, his foot won't go down as far, and both feet are affected by the IK, so it will lift both feet up. But there's no reason for the actual animation to be in control rig, it just is for this demonstration. So I'm just going to give a quick overview of how this has been set up within control rig, but feel free to skip ahead to the part where we actually do the events and handle that. So the first thing we do, we're going to take a look at the construction event. And if you're familiar with blueprints, you can think of this as begin play. So this happens when the whole thing is constructed, when it initially is created. So what we do first is we use this get children node to get all of the children of the root bone. So that's, if we look at the rig hierarchy, all of these bones. We've got recursive ticked, and that means that it will get all of the children bones. If we don't have that ticked, it would just get the direct children of root, which would just be these three. But we would need more than that, so we've got recursive. So it's basically just getting every bone that's within the hierarchy that we've imported. From there, we loop through all of these bones that we found, and we do some basic checks before we carry on. So it's just a regular branch, just an if statement to check should we continue or not. So what we're checking for is, does this current bone that we're looking at, so we're iterating through every single bone, does this current element, if we drop down the element, you'll see name, does the name contain foot underscore? And does it also not contain IK underscore? And the reason we do that is because if we just search for foot in the rig hierarchy, you'll see that there's the foot L, foot R, but then there's also IK foot root, IK foot L, IK foot R. And we don't want those, we just care about the actual foot bones. So we check it's got the word foot and doesn't have IK, and then we continue. And whatever we get, so whatever passes that test, gets added to this array, and we're calling it foot array. So it's just the element that we're currently on gets set, added to this foot array. And the foot array is set to a rig element key. That's a variable type. So it's just a reference to the current bone that we're looking at. So it's a reference to the foot, and this is set to an array. So after the construction event, we go into the forward solve, which again, from Blueprint, you could think of this as the tick event. This is happening every frame. And the first thing we do is set a variable. So this is just a variable I've created called timeline, which is a float, which just keeps track of the current time. So we get whatever the current value is, and we add the delta time to it. So the time since the last frame. So this just constantly increments this value. But we don't just set that. We do a modulo, which is a node which will divide by whatever b is and output the remainder. So it will take the value that we've plugged into A, take out all the multiples of 3 in this case, and whatever is remaining, it will pass on. So if the number was like 3.7, for example, it would take out all the 3's and just pass the 0.7. And what this essentially does is anytime the number goes over whatever we set in B, it will treat it like it's 0 again, because it will be resetting, because every time it goes over, it's taking out that whole multiple and it just resets back to 0. So what this gives us is a number that loops between 0 and whatever this number is set to. And the reason we're using this timeline is just to control the animation. So we can ignore this first path. This is a sequence, so it does A first and then B. We'll ignore this for now because this is where we do the notification information passing. So what we're going to look at first is the B path. And what this does, firstly, we set the transform of the pelvis bone. So we get the current transform of the pelvis bone before any modification has happened. And we pass the values in to a set transform which sets information on the pelvis. So we pass the rotation directly, the scale directly, but the translation, we add a value to it. So we're adding a vector to the current translation, and then we set that new modified version on the translation. And what we're adding to this is based on our timeline. So we take the timeline, and this curve is essentially a remap, but it's a little bit more advanced where you can put in the exact points of the curve, and it outputs a number between 0 and -12. So this is for the x-axis offset, so that's moving him left to right. And then also for the z-axis offset, we do a similar curve, so it's mapping it in the same range, but it's mapping it from 0 to 10. So just for example, if I change the 0 to 10 to 0 to 40, you'll see that the up and down motion gets exaggerated. If I set it to 0, there's no pelvis up and down, but it's still got the x offset from above. So I'll just leave that at 10. And then we're updating the pelvis location from that. But then what we do is we get our foot array, where we added each of the feet, and loop through all of the elements of this foot array. And long story short, ignoring all the wires and all the mess, we then plug into a basic IK node, which just does inverse kinematics of the foot. So we tell it the location the foot wants to be, and it does the calculations for where the thigh and the calf should be to get the foot into that position that we set. So what we're doing is we're getting the transform of the current element in this foot array. So let's say it's the foot L or the foot R. And what we do from that, we take the translation and we add some value to it, which I'll cover in a second. After the value gets added, we output from this into the translation output. So that just affects where the bone actually is. But we don't want to modify the right foot, we're only dealing with the left foot. So what I'm doing is an equals 0 on the index. So the current index through this foot array, there's two entries, there's the left foot and then the right foot. So if the index equals 0, we've got this select, which is actually called if in control rig. I think it should be called select for less confusion, but if this current index that we're modifying at the moment and passing through to this basic IK node, if that's 0, then we're on the left foot, and we're going to do whatever's plugged into the true is going to be passed along to the Y, and we've done the same for the Z axis here. Otherwise, if it's 1 or anything greater than 1, it will do whatever's in the false branch, which is 0 and 0. So no modification gets made, in my case, if it's the right foot. But if it's the left foot, we're using the same timeline that we used to control the pelvis offset. But now we're mapping it differently based on different curves, which just control how the foot is moving up and down. So this is for the z-axis for up and down, so you can see this curve is what the foot's doing. And this one is just for moving it forward, so it doesn't just move directly under, it just moves slightly forwards. And just to demonstrate, so currently the z offset is being remapped from 0 to 45. If I turn this down, so I change it down to 15, you'll see the foot doesn't really lift high at all. And if I change it to some high value, it'll go too high and lift higher than it should. So I'll set that to 45. And then we're adding that to the existing position and then setting the values. And also we're doing some primary and secondary axis setting of the IK, but I'm not going to cover that in this video. And my previous video on the spider procedural walk animation should cover most of this in detail, but I'm just giving you an idea of the general setup that I've got. So one thing we do is when we find the foot position, we do a trace, so it's a sphere trace from above, so it's the x and y from the foot, but 100 units, to the x and y of the foot, but minus 40 units, so that's under the ground somewhere. So it's doing a sphere trace in a straight line down. Wherever this trace hits is the hit location, and so we're taking the z value, which should tell us where the floor is. We offset it slightly, so we just add 13.5 because the actual foot bone is where the ankle is, not where the floor is. So that's just a value that happens to work for this model, 13.5, but different meshes you'd want to use a different value. So whatever that value is, that should be telling us where the foot bone should be in the Z height when the foot is on the floor or whenever the trace has been blocked. So we use that value in a maximum node to basically clamp the Z value. After we offset the foot, we clamp the Z value based on whatever this value is. So it can never go lower than this. So essentially, the foot can go wherever it wants, but if it tries to go lower than the trace hit position, it will limit it. And then we just plug that into the translation on the IK node. So then it sets the foot to wherever it wants to be, except it can't go lower than whatever this value is. So that's the basic setup. But what we're doing as in addition to that is a workaround so that we can convey this information that we can then read in Blueprint that we can use to trigger events, so we can play a sound, spawn dust particles, and anything else you might want to do based on some information that's within control rig. So to my knowledge, this could be wrong and it may change in updated versions, there's no way to directly send events, so you can't do animation notifies from within control rig, and I don't think there's any other way to relay any events or information to blueprints. You can do things like control materials, so I think the functionality is possible and you don't have to use workarounds, but it's just not a feature that's currently in the engine, as far as I know. So what I'm doing is I'm checking the timeline variable and checking if it's within a certain range. So if it's above 8 or 0.8 and less than 0.9, then I set a vector to 1, 0, 0. And if it's not, it's just 0, 0, 0. And the way that we relay this to the blueprint is I'm encoding it in a bone that we're not using. So the IK foot L scale is where I'm setting this. So the IK foot L is this bone, which I'm not using at the moment. This isn't used within the animation. It's not a visible bone. It doesn't control any actual mesh. And I'm getting the transform of this bone, setting it on the same bone, so the rotation and the translation doesn't get changed. But for the scale is going to be set to either 1, 0, 0 or 0, 0, 0. And this draw transform is irrelevant. So I'm setting some values on the scale of this, which within Blueprint, if we get a reference to the skeletal mesh, and then we do a get socket transform set to IK foot L, which is the one that we were setting the scale on, break the transform, get the scale, read the X value. If it equals 1, and also we haven't just recently played a sound, just so it doesn't spam sounds quickly. If that's the case, then we delay the next time the sound can play, so again, so it's not repeating the sounds, and then we play a sound. So if I hook this up, anytime that this scale value of the IK foot L reaches 1, it will play a sound. So currently, this is just based on the timeline. So we're just checking the time in the timeline to make sure it's between these values. Not an ideal way of doing it. This is just for a demonstration. What would make more sense would be checking it from the trace, so you see how far the foot is away from the floor. So you can see if it should just be hitting the floor, something more complex. And that would mean that if there was a box blocking it, the event would trigger sooner. But for this case, it's not really noticeable that the sound is out of sync slightly if there's a box there. And in fact, it looks like it's in better sync if there's boxes there, but yeah. So we've got the event just by reading some value we've encoded into the scale. But let's say you wanted to spawn a particle system and you wanted to spawn it where the foot actually was. So rather than getting the transform of the IK foot L, what we could do is just get the actual foot L and set that transform that we've got onto the IK foot bone. So we're reading it all from the same place, except we've modified the scale. And now when we read it, when we read from the IK foot L, we're getting the translation and rotation of the actual foot bone because we've sort of just combined it into one, and then the scale that we've set. So just an example, if I did a draw debug sphere and we plug that in, and we use a location from this that we're reading from IK foot L, you can see that that's not working. And the reason that's not working is because I've done it wrong, and we're setting these values before we actually do the modification. So I'm just going to swap these, so it's B and then A, and I'll just quickly reorganize things. So the second thing it does is it sets these values, so it gets the current value of the foot and sets it on the IK foot L bone. And now, when we see what happens, you can see that this sphere is tracking where the foot L is. It's not really tracking where the foot L is, it's tracking where the IK foot L is and playing a sound. So all you would need to do from that point is, if it makes it past this branch and you want to play a sound, you could also do spawn system at location to spawn a Niagara system, and you just use its location as where it would spawn it. So that's a long workaround for something that should be very simple and easy to do. And it's very likely that they'll add this feature because I think it is possible to do. There's no technical limitation or reason they couldn't do it, where you would just, if based on some event, you would just do an anim notify, or maybe you would just set some float value that's relaying to Blueprint or somewhere that you can read from control rig. But currently you can't do that, and a few people have asked me about this. So I thought I'd just make this quick video to show how it's possible to do as a workaround for now. And if you want more detail on how to set up control rig to do procedural animations, I've got a video on this channel which is to make a spider walk cycle, and I've also got a course on Udemy that covers it in more detail, which covers how to do procedural animations for humans. So check that out and like and subscribe.